Hey guys, so I'm going to go through this question. I did it in video form just because we've been going through a lot this week, and in case we didn't have time to get to this by a certain time, you can do this on your own. This is very straightforward. Now, this question is going to seem really long. It's only because we're applying everything that we've already done just to do this last step. Okay, so as I go through this example, you're going to see what I mean by that. So follow along, and yeah, again, don't be hesitant to reach out if you have any questions, but again, this is just all buildup of stuff we've already done. So in a double displacement reaction, 10.8 grams of silver nitrate reacts with 7.02 grams of calcium chloride. If 7.5 grams of silver chloride is produced, calculate the percent yield. Okay, so that is what we're trying to solve for. So we have all these steps that we need to go through. So let's start. First thing we need to do is find a balanced equation, exactly like we've been doing with respect to doing a mole ratio. One thing too, guys, if you're watching this, I'm assuming that you did read through your textbook questions, your textbook pages and questions. So yeah, okay. So we have silver nitrate, so that's AgNO3. Okay, you guys know that from our last unit. Then we have calcium chloride. Again, last unit. If you're unsure where these are coming from, make sure you ask for help because you should know this by now, okay? Okay, so what do we get? It's a double displacement reaction. So our silver is going to go with our chlorine and our calcium is going to go with our nitrate. Okay, so again, all stuff from last unit. So we're going to have silver chloride, and we're going to have calcium nitrate. Again, okay, so make sure that you guys check your periodic tables for the charges. If something's multivalent, you know how to cross it over. Calcium in this case is not multivalent, but it has a charge of 2. Nitrate has a charge of 1. Crossover. Okay? So next thing we need to do is balance. So what I'm going to do actually is I'm going to write the order of what I did everything just to the side. So first thing I did, come up with an equation. Okay, so 2, balance, equation. So, silver, there's 1, NO3. Okay, NO3 here, there's 1, but over here, there's 2. So that means I need to throw in a 2 in front of here. Now that I have 2 silvers, as you can see, I'm going to have to put 2 silvers in here. Okay, calcium, I have 1 on my reactant side, 1 calcium on my product side, and then I have 2 chlorines here, product side, 2 chlorines. We're done. Good. So I've done that. So now I need to figure out what the limiting reagent is, or reactant. Okay, so that's my next step. So how do I do that? Well, I determine the moles from the masses that I was given in the equation, and whichever mole is less. So I have 10.8 grams of that, and I have 7.02 grams of that. So I have to do the limiting reagent. Okay. So I'm going to do, for AgNO3, I have to find the molar mass of AgNO3. Again, you guys can write this down. You can do it on the side of the piece of paper. Just don't make it too messy so I can still read what you're doing. I'm just looking for a periodic table. Look, wasn't prepared. There we go. Okay, so Ag is 107.87. Nitrogen is 14.01. And oxygen is 3 times 16. So I got 169.88. So that gives me 0.06357. So again, our final answer due to this question should have 2 sig figs. We'll wait till the very end. For now, I'm just going to carry 4. It doesn't really matter until the end, but the more the better, okay? So I'm going to divide this by the amount of moles this has, so it's going to be 2. Again, all stuff you know, it's all limiting reagent stuff. So I've got 0.031787 moles, okay? So I'm gonna do that. Now I'm going to do it again for calcium chloride. Calcium is 4008 plus 35.45 times 2. .02 divided by our molar mass. Very similar moles. We're going to divide that by 1, right? Because there's only 1 mole there. So it's the same thing. So what is our limiting reactant? Well, this guy is, because it's a smaller amount. So limiting reactant. Okay, so that means I'm going to be using this moles for when we do our mole ratio. Okay? This section here is just to determine the limiting reactant. Okay, this is just an extra step. So we're not using the 0.031. We're using the 0.06357. Oops. Okay, so that was our limiting reagent. Now we're going to do the mole ratio. And then again, going back to our question, silver chloride, I'm going to go like this. Silver chloride is this guy here. So I could have actually put its mass in, but we don't really need it right now. 7.5 grams. Okay, so we're going to do a mole ratio so we can figure out the amount of moles of AgCl, so silver chloride. And the reason why we're finding the moles of this one using silver nitrate is because silver nitrates are a limiting reactant. And if we get it into moles, the reason why we use moles and not just mass for ratios is because moles are like the same playing field. Okay, it's like the same units, where yes, grams and grams are the same units, but with at least the moles, we're getting down to the specific amounts of atoms, because atoms weigh different amounts. Okay, so what are we doing? We are comparing silver nitrate with silver chloride. Okay, so we're doing silver nitrate because that's our limiting reagent, and we are doing silver chloride because we know that 7.5 grams of it is produced. Okay, so that's the amount in question. So how many moles of AgNO3? We have 2. How many moles of silver chloride? We have 2. Again, we're going to use 0.06357. Okay, that amount is here. Like I said, we're using this amount of moles. So that means we're going to do 2x is equal to 2 times 0.06357. Three, 6, 3, 5, 7, 0.12714. Now we have to divide that by 2. Right, look at that, same amount. Okay, so this is the amount of moles of AgCl. Okay. Now, oops, I haven't done this. We've done a mole ratio. Now again, these steps are going to look a little different per question, okay? Sometimes we don't need to do every single one of these steps. I'm just laying it out just to show you that it's all stuff that you guys have done before. We're just applying it all into one thing, okay? So now that I have the moles of AgCl, I can figure out the amount that was actually formed from this reaction here, okay? Or sorry, I just lied to you. We're going to figure out how much should have been formed. So this tells us what I'm about to find is if this reaction happened perfectly, this is the amount of mass of silver chloride we should have got. So we're looking for mass, so N is equal to M over M. We're going to rearrange this equation. The moles is 0.06357. Okay, that came from here. Our molar mass, 107.87 plus chlorine, 35.45, 143 for 32. So I'm going to multiply those two together. I've got 9.1108524 grams. So this is where our sig figs come into play. Like we said, from our question, the number we got that was the smallest was 7.5. That means we're going to use 2 sig figs. Okay, go down here. 1, 2. The 1 keeps the 1 the same. Okay, so if this experiment went well, we should have got 9.1 grams, but we didn't. We got 7.5 grams. So this is where the stuff that you're learning this is where it comes into play. All the other stuff you've already done. So 4% yield. Now what I'm going to do is I'm just going to slightly move all this stuff over. There. Percent yield is actual yield over theoretical yield. So I'm just going to change it to percent. Actual yield is what we got. Okay, so when we ran this experiment, what we got, what was the outcome? Well, that tells us 7.5 grams of silver chloride is produced. Okay, so it's going to be 7.5. The theoretical yield, look at this, is the amount we should have got. Okay? Don't mind my awful grammar. This is the amount we should have got. So it times that by 100. So the percent yield, 7.5 divided by 9.1 divided by, just kidding, times 82.4. Again, it's 2 sig figs, 82%. Okay, so therefore, 82% yield for this reaction. Okay, so think of it as the test is out of 9.1, you got 7.5. Okay, so that means you would have got 82% on the test. So when going through this equation, find the mass produced. Sorry, I went sidetracked. Calculate percent yield. So again, when you're reading through these questions, figure out what's the question asking. Is it telling you what the test is out of, or is it telling you what you got on the test? So, to recap, everything, now I'll highlight it in, let's choose a different color. This blue color. Everything up to here was already done. This blue highlight was the only thing that was new. But you had to do all this other work just to be able to do that new spot. I know. So is it very likely that you're going to get a question like this on your test? Oh yeah, because you have to determine an equation, balance an equation, find the limiting reactant, which is using our equation N is equal to M over M, do a mole ratio, calculate the amount of moles, and then do the percent yield. Big question. I trust you guys. I know you can do it.